So today we will discuss about the Galilean telescope, Galilean telescope, right? So basically, it was discovered and it was made in 1906, and it is also known as opera glass. And obviously, it was it was invented by Galileo Galilei, so that's why it is known as Galilean telescope. Basically, we talk about the working principle. First of all, it is basically it is an optical instrument which is used to see the objects that are already on the earth, but they are quite distant, they are quite far away. It's an optical instrument used to see objects that are already placed on earth, that are on earth, objects that are on earth but very far, but they are very far. So that's so this is basically work of the Galilean telescope. If we talk about the principle, basically it increases the visual angle. In every telescope and compound microscope, the basic principle is that it increases the visual angle. If we talk about the construction, basically it uses two lenses. One is convex lens and other is concave lens, right? In previous telescope we have used the same lenses, but here we use dissimilar lenses, right? So let us look into the how the image is formed. Basically, if we talk about the object lens, that is basically convex. It is convex and it has large focal length. Its focal length is quite large. If the focal length is large, it means the aperture is also large. Aperture is also large, right? And the image which is formed by object lens is basically real, inverted and diminished, right? The image is real, inverted and diminished. If we talk about eye lens, right, basically the eye lens is concave lens, right? And its focal length, it has small focal length. It has small focal length. If the focal length is small, it means the aperture is also small, right? Aperture is also small. And the image which is formed by the eye lens is basically vertical, erect and magnified, right? So I hope it's clear till here. So now we will discuss about the formation of the image, how the image is now formed. Okay, consider that here we have here we have a principal axis. This is principal axis, and here we have the convex lens, which is our object lens basically, and this is one focal length, this is the other focal length, right? Okay, we know that the object is placed on earth, but it is very far. It means the image, the object is on infinity, so obviously the image will form on the focus point. So from focus point it will move to the focus, and from the optical center it will move like this. So these are the parallel lines. It means they are coming from the infinity, right? So let's name this CM and let's name this A. Now this is object lens. Now we have to use the concave lens, which is basically eyepiece. This is basically your eyepiece, the eye lens, right? The image is formed over here. So now this is its optical center. From here, image will go here, like this, and from the optical center here. So the image will form something over here. So image will be, the image which will be formed by concave will be magnified, virtual, and direct, right? So you can see over here. So here we have, like, this is known as B. Okay, from the distance from image, like this focus, to the object, like from the optical center of this object lens, is known as focal length of this object, and from here to here it is known as FE, right? This is basically the image diagram. And now you can see here we have two triangles. One triangle is this, and other triangle is basically this whole triangle. We have two triangles. So this angle is basically known as beta, and this known as alpha, right? So if we talk about, like, in angle ACM, we have to find the alpha, right? And basically we know that magnification is basically equal to beta upon alpha. So here we know that 10 alpha will be equal to perpendicular upon hypotenuse upon base. So perpendicular is CM, and the base is basically FO. So here alpha is equal to CM upon FO. This is equation number 2, and this is equation number 1. Now angle basically BCM, and angle BCM, we have to find the beta, right? So here we have 10 beta, which is equal to perpendicular upon base. So here perpendicular is basically the CM, but the base is FE, right? So we will put these values in this equation, and it will be like magnification is equal to CM upon FE and CM upon FO. Now it will be CM upon FE multiplied by FO upon CM. CM cancel. So here we have magnification, which is equal to F, like the focal length of objective lens and the focal length of eyepiece. This is the magnification of the Galilean telescope. If we talk about the length of the telescope, like the length of the lenses, it will be basically equal to F, or like the focal length of object minus focal length of eyepiece. Why? This hole is basically, this hole is focal length of object, and from this to this is basically the focal length of eyepiece. So we have to find this distance. So when you will minus this from this, then you get this distance. That's why the length of, basically here, the length of the telescope will be, the length of length between two lenses will be equal to focal length of object minus focal length of eyepiece. So I hope it is clear to you. If you have any kind of queries, you can ask me in the comment section. I'll be very glad to answer you guys.